So ideally, the labs are scheduled so that what we do in the lab will reinforce what we're learning in the lecture. So I'm going to look at going to Brightspace, and here's the course, and same procedure as always. Go to content, and then you'll get to start here. And you have access to everything. There's the syllabus, and you're going to find everything in here. Well, it's a different syllabus, of course. But it's laid out the same. My contact information. Let's see. It's a special safety rules and contract. Okay. You got one of those already. There's a safety contract. And all you have to do is read that and then fill in the information on at least one of those copies. There are 2 copies of the contract. One is for you to keep and the other is to give to me. And the reason that I want you to keep a copy is so that you know what you gave me. So I'll give you a couple of minutes to fill that out. And we'll talk about safety all the way through the semester. So we're not going to stop and belabor any points, except to say that when you come in the lab, your shoes have to be closed-toed. You got to cover your feet, and you have to have a lab coat. So you need to find a lab coat somewhere. I think there's a brick and mortar store here somewhere that sells lab coats. Can't remember where it is. It's out. I think it's on Eisenhower, out toward those cell phone towers in that neighborhood. Or you can buy it online. You won't need it for the first lab because that's, in fact, we can do the lab in here. It's graphing techniques. You'll need it for the second lab where we actually go in the lab and do some things. So you'll need the lab coat and wear some type of leg protection below the lab coat, right? Ladies, you can wear, I don't know, pantyhose or long pants. Guys, I wouldn't advise shorts in the lab. Sorry. Cover your legs. And then we have eyewear, eye protection. But they're so old, some of them are kind of scratched. It's hard to find a good one. You may want to invest in a pair of over glasses. They don't have to be bona fide goggles. Or if you wear glasses and your glasses have polycarbonate lenses, which most of them do these days, then your eyes are protected. Or you can wear those glasses. In fact, I've got some in the lab. I might have enough to go around to give you a pair. But you do have to buy your own lab coat. I don't have any extras of those. Well, while we're on the subject of safety, best thing you can do when you go in a lab, any lab, to be safe, is to know what you're going to do before you go in there. You don't go into the cookbook and try to wing it. You know what you're going to do before you walk in the lab. And that's the purpose of the lab notebooks. I'll talk about that. I probably ought to shut up and let you finish your job. You missing something? Okay. So you should have 2, 3, 4, 5, 6, 7, 8, 9, 10. Should have 10 copies.
We have to do the student number. No, never mind.
I
I think it's on.
can do that if I have it handy. Yeah, no.
I think I
No, you don't have to get your students.
don't have to do it.
No. As long as you got your name somewhere there. This is the kind of thing I'm going to cut out of the video. Dead air. I only need the one you filled out.
I missed one.
There you go. No, the other one is yours. Oh, okay. You don't have to fill it out. I just made it available. In case you want to know what you gave me. It's like signing a contract. Both parties always get a copy.
I accidentally filled out the contact information as my own first, so that was confusing to me. And
Oh, I see. Okay. All right. So let's see. Let's look at, like I said before, everything I give you in class is duplicated in Brightspace. So there's the contract. There's some other things in here that you can look at. There's an introduction video. I got the class schedule there. These are all the lab exercises right here in one place. So we have a first lab notebook check, and I'll explain that in a second, what I want to see in that first lab notebook check. That'll be next week. Then there'll be a final lab notebook check at the end of the semester. And in between, when we go in the lab, I will check each of your notebooks to see if you prepared for the lab. So that's important that you know what you're going to do before you go in. You don't have to have one for next week, of course, because we're not going to. I'm going to actually, you picked up a copy of it. The graphing techniques. It's important information, but it's not hands-on work in the lab. Okay. Let's see. There's a copy of the Introducing Graphing Techniques. This is an informal report. Difference between an informal and a formal report is style primarily. An informal report is one in which you just take the hard copy document I hand out and you fill it out, hand it back in. A formal report is it has a certain style and progression. And I give you an example of one of those here, and this one. And you can see what a reasonably good report looks like. This is pressure versus volume in Boyle's law. And of course, I took out all personally identifiable information with the student's permission. And it shows you some of the corrections I made and the format. That's a formal report. And each formal report, when I give it back to you, will have one of these rubrics on the front page. That's how I use, that's what I use to grade. Okay, so that being said, you can access these anytime, and they're usually in each one of these lab exercise modules. There will be a discussion video that I've recorded previously, and it will give you some introductory material and advice concerning the lab itself. In fact, I got 2 of them for graphing techniques. I've got 3 of them. Let's see. You shouldn't see this one. Oh, I forgot to be a student. Sorry. We'll do that. It can be confusing if I'm seeing everything that the instructor sees. Okay, so now you're going to see just that stuff. Now, the second one is the laboratory techniques. So there's the exercise. And if you click on that exercise, it brings you to this page, and there's the document. And then down below it is a place for you to submit your work. Now, the reports you submit will either be informal or formal, and you can submit them hard copy. Just hand them in to them. Or if you walk off and leave it at home, then what you can do on the day it's due is scan it or photograph the pages and submit them here. And on the day that it's due, based upon the syllabus, the schedule, and I've got it highlighted when each one's due, then you can submit it before 11:59 that night. I don't know why it's not been that. 11:59 is the only option I have. And it'll be counted on time. The first 2 reports are informal. In fact, when we go in to do laboratory techniques where we use Bunsen burner, we use linear measurements and mass measurements and all these various things. That's an informal report also. So you just take the hard copy and fill it out, turn it back in. Some students do it on the spot that day, but you don't have to. As a general rule, and you'll see from the way things are laid out here, the exercise that we did last time is due the day we go in for the next lab. So that could be 1 week down the line. It could be 2 weeks down the line. We could have a spring break in the middle, right? We have 2 or 3 weeks before the next one's due. And then I've also marked off dates when we don't have labs, like February 14th. That's Valentine's Day. We don't have a lab on that day. And notice they're all Tuesdays, except for, I forgot to grade this one out. Last day to withdraw with a W is Friday, the 14th of April. Final grades are due on Monday, the 15th of May, and last add drop day is the same. Okay, grading's key. I might as well stay here and talk about. The lab reports are worth 70%. So since we've got 7 labs, each one is worth 10% of the final grade. Lab skills. That's that's one that's difficult to come by. If you're present for every lab, you don't have major mishaps. Then I usually give you a reasonably high grade for lab skills. Show me that you don't do that. And be safe. The lab notebook. the beginning and the ending grade, and then the periodic grades in between that I check when we go in the lab, those all come together and make 15% grade. Now you may be wondering, well, no. Tuesday, the 9th of May is in the finals weekend. Oh, that's another topic, finals. We don't have a final for the lab. We don't have a final for the lecture. And I'm not sure yet whether they're going to impose a exam schedule for midterms or finals that tell us when we have to come in. What I usually do is since you've already had your work schedules and families arranged around these time slots, finals week, you just come in the same time you normally would. So, unless they tell me different, that's the way we do it. Let's see. I'll let you read the rest of it. That's yeah. And I'll go back to Brightspace because there's some things in here that are useful. Those are all the lab exercises. And if you miss getting a copy, what I try to do is I hand out the hard copy lab exercises at least a week before. So you have time to put them in your notebook, and I'll show you the format that I want you to use in just a second. There's information here, lab notes and reports, how-tos, right? And we're going to talk about those. I think what I'll do is just grab each one of those handouts, and we'll talk about that. I think that'd be more efficient. So let's do that. Done that, we've done that. Introducing graphing techniques. So let's hold on that one for a second. You've also got a copy of a blank rubric. Now, don't ignore this rubric because this tells you what I'm looking for. You want as many circled items on the left-hand side as possible. Those are the highest points. And if you get all of these circles, you can get more than 100 points on that particular lab. Some of the most common errors is when you write out the method, what you did in the lab, the procedure, when you put it in your report, you don't want to say, do this, do that, or we did this, or I did that. That's first person. You want third person, passive, past tense. And what I mean by that is if you measure something with a graduated cylinder, say a graduated cylinder, a 100 milliliter graduated cylinder was used to measure 55 milliliters of water. That's the way you say it. You don't say, I did this or we did that. That and spelling errors, grammar errors are the most common places where students lose points, easy points. So I've also given you one of these, and I showed you that earlier. This rubric, this student, I gave them all 12s. They did have some errors in here, but they weren't significant enough to warrant grading them down. And this shows you the format of the report. Right, so there's your exam report, sample report. But I also give you some guidelines on writing the report. I give you a document here called Common Errors. Right? Once you write your report, or while you're writing your report, pay attention. These are things that most often drag a report down. This one is laboratory report format. It's interesting that the laboratory report format and the format of setting up your notebook are exactly the same. So if you put everything in your notebook the way you're supposed to, writing the report is almost busy work. And you want to set up your lab notebook in such a way that you can go in, you leave your hard copy in your book bag, or you could even leave your hard copy at home. If this is a formal report, of course. The next two labs, you want to bring your hard copy. But when we get to formal report territory, you want to set up your lab notebook in such a way that you take the notebook, go in the lab, and you do the work in the lab with your notebook only. So you want to write up your method in the notebook, and you can say just what it says in the hard copy. You can put that in as your procedure, but you may want to make notes along the way. Say if you need an explanatory note along with it, that's fine. What you want is to be able to perform the lab with your lab notebook only, and 3, 6 months, a year later, go back and take that notebook and do the same experiment with just the lab notebook. It needs, think about it in those terms. Do I have enough detail to do that? Okay, lab notebooks. This is the kind of lab notebook I want you to get. It's permanently bound, right? No loose leaf, no spiral bound. And it's quadrilined. It's not your typical composition notebook, just has rules, straight rules. It's quadrilined. We want quadrilined because on occasion you may want or need to draw a graph. And then you're going to need that format in order to do it. I'm sorry. It's quadrilined. It's patchwork. Yeah. Sometimes these are hard to find. If you can't find one, and I think at Walmart they're up to $1.25 now, maybe $1.50. But I bought these back when they were only $1. So if you need one, I'll sell you one for $1. But how do you set up your notebook for the first inspection? Let's see. That's what this handout is for. Right here. You need a name, and I took out the student's name and put red letters in there for it. And you need what the course is and what the semester is. Right, so you can identify when this notebook was used. And then on the inside, this example gives you an example of a table of contents that you're going to need. I'll show you where to put that. And then one experiment, how you set it up, what it looks like in your notebook. That being said, after you've labeled the front, then you want to go in and with an ink pen, everything in this book goes in ink. You want to label each page. Like this is page 1, right, upper right-hand corner. Flip it over, that's page 2. So what you'll find is that all the right-facing pages are odd numbered, and all the left-facing pages are even numbered. Okay, they're around 200 or 210 pages. Do them all. We may not use them all, but you need to number every one. I will look for that. Okay, once you get them numbered, and you'll notice that if you go through and you get interrupted and you make a mistake and start numbering them wrong, keep that in mind. All these pages have to be odd numbers. So if you end up with even numbers over here, go back and check. You might have missed one. Okay, then you need a table of contents. So you just write table of contents up here. And then as we do each experiment, you'll write in here the name of the experiment and what page does it start on. That's all you need. Because it's going to run until you put in another one. And it's going to start on the next available page. Right? So you just need starting pages. Right? If you look at any book, table of contents, most of them just put the starting page for a topic. Okay, then you can go to the next page or you can skip. But when you set up your experiment, you put your title in and do it on the odd pages only. Leave the even pages untouched in the beginning. And I'll tell you why in just a second. And write on every other line, because what do you do if you make a mistake? draw a line through it, and you make the correction right underneath it. And if you don't have any space in there, there's no place to write. Now, what if you have a huge error, right? Put a big X through it, initial it that you did it, and then put the correction over here. So it keeps them close to where they were supposed to be. Or if you have a big graph that needs to be drawn, you've got this space for it. Right? So leave all these pages blank until you need to use them. And we're only going to have, what, 7 labs. So you got a lot of room. You can skip pages if you want. And then you want the layout, and that's what this one also shows you. What's the layout that you put in there? The format will also, let's see. Got another document. Is that what it is? Where is it? I don't think it's in my office. Okay. I won't make you walk up here for this one. This gives you the headings, the information that you want to be sure you have placed in your notebook based upon the hard copy. So you're going to have a title. We talked about it already. Put your title in, and you go back to the table of contents and write in the number, the title and the number for your table of contents. Then you want an introductory statement. Why are you doing the lab? What's its purpose? And you can usually get that from the hard copy too. But it's useful to put it in your own words. Because if you put it in your own words, then you're starting to understand what it's about. Then there's safety concerns. What do we need to watch out for in this lab? What could possibly hurt you or kill you? Then the materials required. What are we going to use in the lab? What are the reagents, the chemical reagents, or the measuring devices, balances, so forth, meter sticks, whatever the case may be. Just list those, and you can do those as a dot list. Then procedures, and these procedures are what you are going to do, right? And those can come straight out of the hard copy also, with your comments if you want. What are the procedures? Step by step. Sometimes chemistry is like cooking. Well, you can't leave the spoon. It's a matter of timing in many cases. Sometimes you've got to have something going on over here and something going on over here, and they have to be timed just right so that they come together at the right time. You put them on the table for people to eat, and everything's, you don't have one cold dish and the rest are hot dishes. So it's a matter of timing. And when you write your procedures out, you want to keep that in mind, right? What do I need to do so that everything meshes together? Say you've got a chemical reaction that's going to take a while to develop, right? You start it first and then set your timer and go do something else. So those are your procedures. Some of the labs have pre-lab questions to get you in the mindset for the lab, and they may involve calculations. Those pre-lab questions go in your lab book plus the answers and any calculations that you needed to do with them. Those are completed. You want to reserve a space for your data and or observations. Make room for them. Very often, and example is this lab report. Yeah, this one, I think. Boyle's Law lab report. You'll see that tables were necessary, right? So if you know that you're going to have a list of data that lends itself well to filling in a table, then set up your table in your lab notebook beforehand with spaces for all the numbers that you're going to need. If you don't know how many numbers, then make it big enough to cover everything. There's lots of space. And you have that in there under data and observations. If you have places set aside for that information that you're going to make measurements, or just list with a space, an underlined space. The advantage to that is if you're working through the lab and you get down here and you see some empty spaces up there, stop. You missed something. Or you go up there and say, oh, we skipped that for a reason. So mark it out. Okay. It helps you work more efficiently. Then you want to reserve space for calculations. Okay. So you can show your work. What kind of calculations did I do to arrive at these answers? And the calculations may be necessary to fill in parts of that table with data and observations. That's a possibility. Then you want to reserve a space titled Discussions and Conclusions. What did you learn? I mean, summarize what you did in the lab, plus what does it mean? Right? I mean, this is not just busy work. What do the results of these experiments mean? Do they mean anything? And then reserve a space for post-lab questions. In this case, you'll have the space reserved for the questions, but you won't have the answers yet because you haven't done the lab. And some of the labs, the work that's in the post-lab questions is applicable to calculations and data input, right? So if that's the case and you've already done the calculations that the post-lab question asks for, you just reference where else it occurs in the document, like in this table on page such and such. Then when you write your report and you fill out your section on post-lab questions, you can reference to another part of the report so that I'll know where to see, okay, they did that before, I go look, yeah, there it is, okay, check it off. And that's it. That's basically the structure of your report too. Well, you've got an example for the report right here. And there's another document for lab report format. Okay, so that takes care of the notebook. Takes care of formal reports, except one thing. And I hate to have to do this, but I've had it happen before. Sometimes it's by honest mistake, and sometimes it's by malicious behavior. Is plagiarism. In English classes, it's pretty evident what plagiarism is. It's pretty easy to know yourself whether you're plagiarizing somebody. But when you're writing a lab report, sometimes it's difficult to know. So that's why I put this document together. What is plagiarism in a lab report? And we won't have to go over the details, just read it and be mindful that you're in a group with your one or two partners and you're doing the experiment. Obviously, your data is going to be identical. I mean, the numbers that you measure are going to be the same. Your calculations may be different, right? Because you're going to do them yourself. The conclusions you draw from your calculations may be different, should be different. Well, they could be similar. And you can discuss them as a group, but when you write them in your notebook and when you put them in your report, they go in as your own words, right? They come from your head, not your partner's head. Okay. And that's not just some draconian measure that I'm imposing on you. That's for your own benefit. I mean, what we want out of this course is clear thinkers. You can take information in, process it clearly, and produce logical results. That's good in every aspect of life. Right? For instance, when you walk into the polling station and go to cast a vote, you don't just look down the list. I hope you don't. Just look down the list and find, oh, that name looks nice. I'll vote for them. Right? No, you know something about the person. What do they stand for? What are they going to do for you if they get in office? What are they going to do against you if they get in office? You don't want to vote for them, obviously. That's why I didn't vote for the last president, because I knew what he was going to do. Oh, the one that's in there now, not the last. His reputation preceded him. Anyway, any questions? Well, we should have time next week to do this graphing techniques. How much time do I have? Maybe I can do some introductory remarks. 3:50. Yeah, I can talk about it a little bit. Introducing graphing techniques. In the sciences, humans are visual creatures. That's almost axiomatic. We take in information in chunks, in visual chunks. But when we make measurements in the sciences, when we conduct an experiment, very often, not always, but very often we make linear measurements, right? And we get these big piles of numbers, right? And you get bleary-eyed looking at those numbers. It's useful to take those numbers and express them in some sort of visual fashion. And graphing is one way to do that. It's easier to pick out trends. It's easier to detect outliers, mistakes, data points that you can justify discarding. So we're going to start with the very basics, right? Has anybody done graphing in other courses? Math courses? Yeah, okay. So some of this will be old for you. We're going to use a Cartesian system. And that just simply means we've got an x-axis and a y-axis. We've got an ordinate and an abscissa. Is that right? Or did I do that backwards? X is abscissa. Okay, and in this Cartesian system, you can place your data points, but they come in pairs of numbers. In other words, if you have a list of numbers here and a list of numbers here, and these pairs match one another, they're together for a purpose. For instance, when we go back to pressure volume, right, Boyle's law. Pressure, at certain pressure, you get a volume. At another pressure, you get a different volume. So those are pairs of numbers. And we can plot those numbers, right? And if you took a math class, they may have made you say, write the value for X and Y that goes in for that point. And then you can plot another one. And then you can, sometimes you can connect the dots and make a curve. Well, for most of our work, we're going to be focused on this region here. These are all These are all positives. These are all positive Y values, X values. These are all negative values, and these are all negative values. We usually don't delve into these areas unless it's by way of extrapolation. In other words, you may have a series of numbers here, you draw there, and then you say, all right, what if I extend that line down here? Well, it's in negative territory now. So that's the only time you need these negative sections of the graph. Here, 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 will usually stay in the positive areas. But I think you do have in this exercise, you do have some negatives in here. So these are called quadrants. So we say in the positive quadrant is where we spend most of our time. Okay. This is called the origin. right? And what's the XY value for the origin? 0, 0. Right? That's zeros. Negative values this way, positive values that way. So when we have those lines, when we have the data points here plotted, and say we have some like that, and some like that, some like that, sometimes we try to do a best fit line. Scientists typically try for straight lines when they can get them. And sometimes that requires you to transform the data, the measurement somehow. Invert it, take the log of it, something like that. But if you just plot the values and they're like this, and you say, well, that sort of looks like it's straight. I've got some that are off the line, but what's the best fit line for there? The best fit is the one that minimizes deviations from the line. So you wouldn't draw a straight line through here or through here. It would make too much deviation for these. So you draw through the middle. And there's your best fit line, or your best fit curve. Now, you've got values here. Some of the values may fall on the line. But what if you want to interpret the graph, the line, for values that were not part of the measurements? Right? Say, this one was actually measured. That X value and that Y value go together. But what if you want to say, all right, what if X is here? Right? Go up here. What would the Y be for that one? There it is. That's called interpolation. When you manufacture a data point based on the best fit curve. That's interpolation. And that's the most reliable what ifs in your data set. It's the interpolation. But sometimes we want to go outside the line. Right? It doesn't go any further. It goes that way. Right? In that case, if you go here and here, and you say, okay, that would be the Y for this X. That's called extrapolation. You're outside your data range. Right? And that's when things get a little dicey because you really don't know what this line is going to do. Maybe the line goes like this. You don't know. So extrapolation is more dangerous than interpolation. So when you have a set of data points and you've got a sheet of paper with graph lines on it, and I think you do, yeah, on the back sheet of this paper, and I have extras. You'll notice that on these pages, you've got dark lines and light lines. The darker lines and in between the light lines are 5 divisions. So how do you know how to manually draw your graph? Okay. Excel will do a pretty good job of drawing data if you put it into the spreadsheet and do the jump through the right hoops. You can make it draw your graph. But it's based upon earlier hand-drawn graphs. Excel came later. So how do you know what to do in order to get the best looking graph, the one from which you can derive the most benefit, most information? You need to know what your data looks like. You've got lists of numbers here like that. You look for the largest number and the smallest number on each side. Largest and smallest, largest and smallest. And then you say, all right, what range is that going to be? Then you have your sheet of paper. Maybe you want it this way. Well, maybe you want it this way. This is called portrait. This is called landscape. And you've got the lines drawn in there. So what you want is to maximize the spread of your graph on that sheet of paper. Use up as much of it as you can. But you want to do it in regular intervals that are lined off, so that when you go back to do that interpolation, then it's easier to read the numbers. Okay. So you look for the largest and the smallest, and you ask yourself, what divisions will give me regular? So maybe you've got a graph that you want to draw in here, and you say if you go regular intervals here, then maybe your data, the ones you picked, would put your final measurement out here. Right? That would do. So you got to go back to the drawing board and reduce it by a factor. So maybe you're only going to be able to use this much of your graph for the data. And you do the same thing for the y-axis. You set up your axis, then once you know what you're covering and you know what each one value is, then you label your values on each of these major axes, and then the divisions in between will be fractional of that. If there are 5 divisions between them, it probably would be nice if you could do an even number from here to here. Then it would have 10 divisions, and that puts you in the next decimal range. Otherwise, you've got to use 2/10 division. Then you name it. You only have to label the major divisions. Right? Label the major divisions. Right? So you got those labeled, and then you also want to say, it's okay. Screensaver. And then you put the numbers on there. Then you want to say, what are those units? Right? Because if you don't have units, right, the numbers don't mean anything. So you put the units of measure down here and you say, let's see, you want to label the axis also. So let's say this is pressure. And you're going to measure it in atmospheres. Right? And this one is your volume. And you're going to measure that in milliliters. Okay, or you could do parentheses. What else are we missing? Title. What are you trying to show here? Right? This is the relationship of pressure to volume of such and such a gas. Okay, got your title. Then you put your data points in, or actually with pressure volume to be like this. And then you draw your best fit curve. So those are all the elements of a good graph. One thing you got to remember is when you draw a graph, the graph itself must stand alone. Right? You can extract the graph from the paper and it will tell you something in and of itself. It may not be the whole story because you need the whole paper for that. But it will stand alone and tell you something. It'll tell you this relationship. Sometimes they have captions that give you a little more information. But graphs have to stand alone. Let's see. And then linear relationships. In fact, you've got examples on page 19, figure 3. The top one is pressure volume. That's boiling water. But notice that's a curve. In fact, it's a hyperbola. Remember what a hyperbola is? A hyperbola is a curve drawn in one of these quadrants, in which an extension of the line in either direction along the axes never touches the line. No matter how far you go. That's a hyperbola. Actually, there's a better math definition, but that's good enough for now. But like I said, scientists don't like curves. So we want to make a straight line out of that curve. Well, here's what we did to do that, right? The graph below it is a straight line. But how did we do it? Well, we have these values of pressure and volume, but we know that the relationship is pressure times volume equals a constant. Right? So you got these values. Well, if we rearrange that equation and we put the volume on this side, what does that do to it? Pressure equals K over volume, right? Okay. Let's split that out. Let's say instead of that, let's say K times 1 over V. There you go. Now we got this variable against that variable, and there's the K. So what is that? Y equals mx plus b. That is the slope of a line, of a straight line. Only now we need to convert the volume into an inverse. So you just say 1 divided by the value, or most calculators have an inverse key. Just put in the value and get the 1 over x key. And that value goes in here. Now we plot this one against that one on our graph. And you get a straight line with a slope of k. Now, what's the y-intercept? The origin. It goes right through the origin. Okay. So how do you graph that? So you set it up so, let's see. We haven't talked about dependent and independent variables yet. Let's do that first. So when we do this experiment with pressure and volume, what is the experimenter changing? The pressure. The pressure on the gas is controlled by the experimenter. The pressure then is the independent volume, independent variable. And the V is the dependent variable. Okay? You watch what happens to the volume when you change the pressure. So how do you plot that on a graph? Well, typically, by convention, this one, the x-axis is the independent volume. And this is the dependent volume. Dependent variable, excuse me. Independent variable. So this would be pressure, this would be volume. So when you plot them up there, you should have pressure down here and 1 over V to plot the data in this format, where you have 1 over V versus pressure. So what does that look like when you actually plot it? Well, pressure is here, and you do the same thing. You've already picked out the best x-axis on your previous one, so it'll be the same. But the 1 over V is going to be different, right? Because if you have a volume of 5 milliliters, what's the inverse of 5 milliliters? 2/10, 1 over 5, right? So it's going to be a different range here. So you got to figure that range out again. It's 1 over V. What are the units of measure? Well, this one's still atmospheres. What about 1 over V? Remember, when you do a transformation of a number, you do it to the units also. So if you take the inverse of the volume, you take the inverse of the unit. So it's reciprocal milliliters. Okay? And then you plot those. And what you should get is straight line. And you put your title in here. And let's see, mark things off here and label them. Right? Same as you did before. And that's the next graph. Let's see. Now there's a required section, and I think we've gotten everything for the required section. Oh, that was pressure, volume, and pressure 1 over volume. Before that, we got to temperature and volume. Now, temperature and volume is a law we're going to cover later with gases. It's Charles' law. Temperature and volume is a straight line right off the bat. The raw data will give you a straight line. Temperature and volume are directly proportional. As temperature goes up, the volume goes up. Right? Heat of gas expands. Whereas you put pressure on the gas, it shrinks. Right? So they're let's see. My mind's gone blank. Inversely proportional. I got it. And there's, after that, if you do that one, well, on page 30, then there's a bonus section. So you can do it or not. It's going to be a little different plot because, and I think, let me check the schedule. In a few minutes. No. We'll do that in the second semester. Where we take acid and base and titrate them. Determine the pH as we go. And plot the pH against added base. But that's what this one, the first bonus is. And I'll give you a hint. As you add base, volume of base, you get pH? Yes, you get pH, which is a measure of acidity. And when you do that, you're going to get something like this. Sigmoid curve. That's what you should expect to see for that. The second one, where it has temperature against time, is going to be what's called a broken curve. It's going to look something like this. Remember, these are bonuses, so you don't have to do this. It's going to do something like, I don't know, like that. And then all of a sudden it's going to jump up here. Right? It's a broken curve. So I won't be disappointed if you don't attempt that one because it's a little dicey. Any questions so far? You've all been very quiet. Kind of scares me sometimes.
So this work was due for the lab, right?
We're going to do this one in class next week.
Oh, okay.
I'm just giving you some introductory.
All right.
And you can read it and get ready for it. And these first two, you don't have to put in your lab notebook unless you want to. You could start with the second one. It might be good to get a feel for it. You know, how you put it in your lab notebook. But the first and second one are informal reports. So if you just do the work, answer the questions on the hard copy, you gain it back.
And it's due next week, or we'll do it next week?
No, we're going to do it next week.
Okay.
So if we look at the schedule, it should be scheduled to do the lab next week. Today's the 17th. So we'll do this one on the 24th. I do want to check your notebook next week. So you need to get a notebook recorded and do the front cover, just table of contents and number all the pages. That's it. That's all you have to do.
And was anything due for regular general chemistry?
Oh, for the lecture?
Yeah.
Not yet. Not till we have the homework and the exam are due on the same day. So you do need to buy Cengage Unlimited if you haven't already done it. Or if you may have had to buy it for another course. If you have, then you don't have to buy it again. You can go in and go into Brightspace and register with the credentials you used on the other course. Once you buy Cengage Unlimited, it's just that, it's unlimited. Okay? No questions? Okay, so Thursday we'll come back in here and knock out chapter 2. And that's it. That's all we're going to do. Just chapter 2.